Hello everyone. This video is on section 11.1 part 1 titled The Distance Formula. In this video I am going to be going over a version of the Knewton Alta assignment for section 11.1 part 1. Now please understand that the questions I see in this version may not be the same questions that you see when you do the assignment on your own. But the objectives will be the same, the types of questions should be similar, so I'm hoping that watching me go over these here helps you out in some way when you work on the assignment yourself. Alright, so here's the assignment page. You will see, you won't see the words preview of, you'll just see the title of the assignment. The mastery bar, right, telling you how far along you've gotten. And the objectives. Now it looks like there's only the one objective for the question, for this particular assignment. And then beneath each current objective you'll have a question related to that objective. And at the bottom of every question there should be a feedback button for which you can send feedback to Knewton if you need to. You will not see the instructor cheat button. Right, this will not be there. But you will see a more instruction button. And if you click on this, whatever objective you're working on, you'll be provided with further reading material and or videos that are related to that objective, and hopefully those help. Alright, so every question in this is going to involve the, beyond the objective, use the distance formula to find the distance between 2 points. Now they're talking about 2 points on the XY coordinate plane, or the Cartesian coordinate plane, whatever you want to call it. Alright, so this distance formula is really just coming from the Pythagorean theorem, and I'll show you how in a little bit here. So in our first question, we're asked to use the distance formula to find the distance between the points 1, -7. Remember, this is the x coordinate, and then after the comma is the y coordinate. And 9, 6, right? So x coordinate 9, y coordinate 6. And then we're asked to write our answer in exact form. Now remember, exact form means don't use a calculator. Don't round it, right? Just leave it as is, in as simplified a form as you can without actually punching it into a calculator. Right? Okay. So before I get into the actual points in the question that we were given, I want to talk about, how do you find the distance between 2 points on the XY coordinate plane. Alright, so this is a hand drawing I'm doing, so it's not going to look perfect. But you have the x-axis, right, the horizontal axis, the y-axis being the vertical axis. And then let's say I give you 2 points on this plane. So this point, I'll just pick some points in the first quadrant. Just know that these could be any 2 points. They don't have to be in the first quadrant. So I picked 2 points. There we go. Point here, point there. And these points have coordinates. So let's say for this first point here, say the x coordinate of this point, right, the number on the number line, the x-axis that it's in line with, let's say that's x sub 1, right, x number 1, x value number 1. And then the y coordinate for this point, again just for this first point here, I'll call it y1, y sub 1. Right. And then I'll do the same for the other point, right? This is, let's call this point 2. And it has an x coordinate let's say that x coordinate is x sub 2, not x squared, right? This is x2. And it has a y coordinate of y2. All right, so the points here are the points with coordinates x1 comma y1. All right, that's this first point here. And the other point has coordinates, x2 comma y2. All right, that's this point that I'm pointing to here. And what we are asked to find, right, what we are asked to figure is what's the distance between these points. In other words, what's the length of this segment? If I draw a segment between these 2 points, right, where these 2 points are the endpoints, the length of that segment is the distance. So I'm going to say, I'll call it capital D. All right, capital D is the distance between the points that we were given. All right. Now, what I'm going to do is show you that to find this, just a generic distance between any 2 points on the xy coordinate plane, really what you're going to be using is the Pythagorean theorem. So what you're going to see here, I'm going to draw a little picture of a right triangle. All right, imagine traveling from my first point with coordinates x1, y1 to the second point with coordinates x2, y2, but remember you can only go left and right and up and down. So here I'd travel to the right this many units, right? And this distance here would be x2 minus x1. Right? You always take larger minus smaller to get a positive quantity for distance. Right? So the length of one leg of this, hopefully you can see the right triangle. Right, hopefully you can see the right triangle. It's this leg here, right? And then there's the right angle, right? And then I travel up, right? Then I travel from this point up to the final point, the point with coordinates x2, y2. And this distance here, right, the vertical leg, this length, would be y2 minus y1. Again, I'm taking larger minus smaller, so we get a positive quantity for distance. And here's, the other leg of this right triangle. Hopefully you can see the right triangle that I have just drawn here. All right, starting at this point, going right, then up, and then if you go through the segment with the length d that we're trying to find, right, that would be the hypotenuse. So since I have a right triangle, we can apply the Pythagorean theorem. All right, by the Pythagorean theorem, remember the lengths of the legs squared added up is equal to the hypotenuse squared. So this horizontal leg has a length of, quantity x2 minus x1. So that leg squared plus, and then the vertical leg, which has a length of the quantity y2 minus y1, all right, that length squared should be equal to the length of the hypotenuse, which is the distance between the 2 points, squared. Right? And then we solve this for d, right? Solve this for the distance between the 2 points. So that means that d, right, the distance between these 2 points, x1 comma y1 and x2 comma y2, is either plus or minus the square root of something, right, this guy here, but I'm going to use the positive square root. Reason I'm using the positive square root is because this is a distance, right? And remember, distance, length can't be negative, All right, so technically you should have plus or minus here, but because we're talking about lengths, I'm using the positive square root. And it's the square root of, that one leg squared, the x2 minus x1 squared, plus, and then the y2 minus y1, right, that vertical leg squared. And I'm going to put this in a nice little box. All right, this is called the distance formula. All right, if you're given 2 points, x1 comma y1 and x2 comma y2, this is how you can calculate the distance between them. All right, so there's the distance formula that they're talking about in the objective title. Okay, so in our particular question here, this first question, and I'll keep the distance formula up top here. Hopefully it's not too bright. All right, there we go. So our first example, our first question, we're trying to find the distance between the points, -1 comma, oh, sorry, I already messed up that. Looking back at the assignment, it's 1 comma -7, and the other point was 9 comma 6, right? All right, so I'm going to do this with a picture and the formula. All right. So first I'll draw a picture, a very, very rough picture, right? I'm not going to mark off all the little individual integers and whatnot. Here's the x-axis, here's the y-axis. And the first point is at 1, -7. So that would be in the fourth quadrant here. 1 to the right, 7 down. So let's say that's here. All right, there's the point, 1 comma -7. So that's in line with 1 on the x-axis and -7 on the y-axis, all right, that point there. The other point is 9, 6, so 9, 6, all right, that'd be in quadrant 1, somewhere up here, let's say. Again, just make sure you're labeling properly, right? There's the ordered pair 9, it's in line with 9 on the x-axis and in line with 6 on the y-axis. And I'll also label it 9 comma 6. And we want the distance between them, right? The length of this segment right here. So again, D. Right, I'll call the distance between them capital D. All right, and just like I did in the previous picture, I'm going to make a little right triangle. So if I were going to go from this point to that point, but only traveling right and up, we'll create this right triangle. All right, there's the right angle there. Now the length of this side, hopefully you can see it, is 9 minus 1. That's 8 units long. All right, I went from x value of 1 to x value of 9. And then the vertical leg, right, I'm going from a y value of -7 up to a y value of 16. That's 7 plus 6, that's 13 units. Or you could do 6 minus -7, right, y2 minus y1. And then by the Pythagorean theorem, 8 squared, right, the length of this horizontal leg squared, plus 13 squared, the length of the vertical leg squared, should be equal to the distance squared, right, the hypotenuse squared. And I'll get back to the formula in a second. I'm just going to cover it up for now. So we have 64 plus 169 equals d squared. Right? Now 64 plus 169 would be 233. Just double check that. 229 plus 4, 233. And taking the square root of both sides, we get the distance between them would be this. Again, it's positive or negative, but we're talking about a distance, right? So the positive square root of 233, units. That's how many units apart these are. So this is equal to the square root of 233. That's how many units apart. Something between 15 and 16 units. apart these are, right? And you can punch this in a calculator and round your answer, but they don't want us to do that here. They want us to leave it in exact form. All right, so this is the way I'm going to leave it. Now, if we can simplify this, we should. Now, 233, it's not a multiple of 3. It's not a multiple of 2. It's not a multiple of 3. It's not a multiple of 5. It's not a multiple of 7, right? 210 plus 23, no. Not a multiple of 11. Yeah, it's not a multiple of 11. And 13. Let's see, 13, 260. 27. No, it's not a multiple of 13 either. And then, yeah, I think that's all I need to check. This is as simplified as this root gets. And that's it. That's all we're doing. All right. Now, you can do it with a picture like this, like I did over here, where I draw a picture and make a little right triangle, and what's the horizontal leg's length, what's the vertical leg's length, and then I can use the Pythagorean theorem to find the hypotenuse. Or I can just jump right into the formula. All right, just here's the formula again, and just make sure you're labeling things properly. All right, so one point I'll call, has coordinates x1 is 1 and y1 is -7. And then the other point I'll call, x2, y2. So x2 is 9, y2 is 6, and then just replace all that junk in the formula. All right, so we have d equals, the square root, big square root, of, and then just replace, the change in x. You're just doing the change in x. Subtract the x coordinates, 9 minus 1. Subtracting the x coordinates and then squaring that. Still inside the square root here, we add and then do the same thing with the y coordinates, right? y2 minus y1, 6 minus -7. And then square that. Right? And then we simplify what's inside here. This would be the square root. Now 9 minus 1 is 8, right? So it's 8 squared plus 6 minus -7 is 6 plus 7, that's 13. And I get exactly the same thing I had over here, right? This would be the square root of 64 plus 169, which is 233. Right, it's exactly the same. Right, so however you want to do it, you can draw a picture, a rough picture, and make a right triangle. Use the Pythagorean theorem there, or you can use the, if you have the formula memorized, you can just make sure you're, again, make sure you label your points properly, x1, y1, x2, y2, and then, take the square root of the change in the x coordinates squared plus the change in the y coordinates squared, and you got your distance as well. All right, but again, either way we're seeing it, the distance between these 2 points we were given is the square root of 233 units. And that's what I shall enter, right? Because again, we're asked to enter it in exact form. Do not punch this in a calculator. Don't round it. Just leave it as is, as simplified as it can get. Wonderful. All right. Now, after every question, whether you get it correct or incorrect, there should be an answer explanation. I highly recommend you read through these, whether you're right or wrong. If you're correct, just glance through it to make sure you got it right for the right reasons, that you didn't just get lucky. Also, they may go through an alternate method that you like better and you may wish to use for future questions. Now, if you got it wrong, definitely read through the answer explanations and try to figure out where you went wrong and, learn from your mistakes for future questions. All right, next question. Now again, every single question here is on the same objective. All right, so once again, we're asked to use the distance formula to find the distance between the points, 0, -10, and -7, -1. All right. And once again, we're asked to write the answer in exact form. Right? So no calculator use here. All right, so here are the 2 points we're given. Now this, I'm just going to use the formula. I'll label the first point with coordinates, x1, y1. I'll label the second point with coordinates x2, y2. Right. Alright, and the distance between them on the coordinate plane, if you were to draw it and measure it out, the distance between them would be the square root, or make a big square root, and then, the horizontal length, the horizontal leg of the right triangle you draw, I take x2 minus x1, right? Negative 7 minus 0, the change in the x coordinates, and square that after you're done. Plus, and then the same thing for the y coordinates, right? So negative 1 minus negative 10. Right? So minus a negative, that's going to end up being a plus, right? And then square that when you're done. Right? So, and then simplifying all this, we have the square root of, this is negative 7 squared will be positive 49, plus, and then here, negative 1 minus negative 10, that's negative 1 plus 10, which would be 9. And we're going to square that. And keep on going here. This is the square root. Negative 7 to the second is positive 49, plus 9 squared is 81. And then 49 plus 81 is 130. So we get the square root of 130 units long. That's how long the segment connecting these 2 points would be on the coordinate plane. And then we try simplifying this radical here. Now that's 2 times 65, which is, and 65 is 5 times 13. This is 2 times 5 times 13, which doesn't have any perfect squares, right? So this radical can't be simplified, so I'm just going to leave it as the square root of 130. All right, so these 2 points, right, if you were to draw them on the coordinate plane, are the square root of 130, units apart. That's something between 11 and 12 units. And if you want to punch this into a calculator and get 11 point something, you can, but we're not asked to do that, right? We're asked to enter the answer as an exact form. So the distance between those points is the square root of 130 units long. All right. So again, read through your answer explanations, please. All right. Next question, same objective. Once again, we are asked to use the distance formula to find the distance between the points 1, 7 and 0, 7. Now, this is ridiculously simple because notice how the y coordinates are the same. So 1, 7 and 0, 7, 1, 7 is only 1 unit to the right of 0, 7. So their distance is 1 unit apart. Now I will still go to the paper and use the formula, right? The formula will always work, no matter how simple or how complicated the numbers may be. All right, so again, I'm just going to use the formula, right? The first point has coordinates x1, y1. The second point here has coordinates x2, y2. And then we'll go through the formula, right? The distance between them is simply the square root of the difference in the x coordinates squared, so 0 minus 1, that quantity squared, plus, and then the difference in the y coordinates, 7 minus 7, squared, right? And again, you're going to see that, if they have the same y coordinates or the same x coordinates, this gets to be real simple, right? This just ends up being the square root of 1. I hope you see that. Because we'll have negative 1 squared is positive 1 plus 0 squared, which is 0. So I end up with the square root of 1, which is just simply 1. Right? So they are 1 unit apart. Now, if you were to draw them, right, if you were to draw the points, here's say 1, there's 7, and then 0. Now, 0, 7 is this point here. And 1, 7 is this point here, right? And hopefully you can see that they're definitely just 1 unit apart, right? 1 unit to this point's 1 unit to the right of that point. So yeah, so easy peasy. All right, and again, please read through the answer explanations. And then we should have just one final question here, where once again we're asked to use the distance formula to find the distance between the 2 points. Okay, so this time I'm not even going to label them. I'm just going to jump right into the formula. The distance between these points that we were given is the square root of, the change in the x coordinates. So 1 minus 9, or 9 minus 1, either way is fine, because you're going to end up squaring these anyway, which will just make them positive. But I'll do it the way I've been doing it, second minus first. All right, so 1 minus 9, squared, plus, and then the change in the y coordinates, negative 10 minus negative 1. Negative 10 minus negative 1. So you got minus a negative, that'll end up being a plus. And then square that. So this is the square root of negative 8 squared, which will end up being positive 64, plus, and then negative 10 minus negative 1 would be negative 10 plus 1, which would be negative 9. And then squared will be positive 81. Right? So this ends up being the square root of 64 plus 81, which is the square root of, 64 plus 81 is 145. Now let's see, that breaks down, that's 5 times 29, and 29 is prime. So there are no perfect square factors in this. This is as simplified as it gets. Alright, so these 2 points, if you were to draw them on the coordinate plane, are the square root of 145 units apart. So something between 12 and 13 units, 12 point something units apart. But we're asked to enter it in exact form again, no rounding, no calculator use. So back here, the square root of 145. Great. And again, read through your answer explanations, please. And that should be it for this version of this assignment. Really short one, just one objective. Again, as I said at the top of the video, please understand that the questions I saw here may not be the same as the questions you see when you work on the assignment yourself. But the objective is the same. You're asked to do the same stuff, right? The types of questions are similar. So I'm hoping that watching me go through 4 questions here helps you, in some way when you're working on the assignment on your own. And thank you very much for watching.